Hello and welcome to this session on Power BI. Today we are going to talk about Power BI, what are its features, what are the basic advantages of using a visualization tool like Power BI, and we will talk about how to install Power BI and other features it provides and the basic setup. So let's discuss what's in it for us today. Now, we will first talk about why Power BI, why it's a popular tool and what problem it solves, what is Power BI, and what are the primary features of Power BI, which you can use in your day-to-day data analytics, visualizations, creating fancy reports, creating meaningful, intelligent reports for your organization, for your personal use, for crunching numbers, for generating reports real time, etc. Now, the most popular tool for Power BI is the Power BI desktop. I'll show you certain aspects of Power BI desktop, and then I'll show you the steps how to install Power BI desktop on your machine. And then definitely Power BI desktop is a free tool provided by Microsoft, but then you can also subscribe for an enterprise version, which is primarily used by enterprises for publishing their data. So we'll see the difference, and then overview of dashboards which can be created, what kind of dashboards can be created in Power BI. So this is the agenda for us today. Now, why Power BI? So generally, visualization tools, reporting tools are required in order to create and prepare and analyze meaningful data. It could be a data for an organization, it could be a social media platform data, it could be a data from IoT devices, but something which needs to be analyzed and some intelligent inferences and data mining has to be done on top of it. Now imagine today we are in a world where terabytes of data and information is getting generated on an instantaneous basis, on minute by minute basis. So it becomes very essential to churn out something meaningful, something intelligent out of it. In the market, there are a lot of other tools which are available like Clix, Alteryx, Tableau and Power BI. So Power BI is a Microsoft product which is one of the most popular products, and it comes as a free to download product, Microsoft Power BI desktop, which is available, and I'll show you a couple of ways how you can install it on your machine. But why Power BI is popular is because it provides a lot of out-of-the-box features, drag and drop features, which we will talk about in our subsequent sessions and classes. But today's session is primarily focused on giving you guys an introduction on what is the purpose of Power BI and what all problems it solves in the real world. So Power BI allows you to view, analyze and visualize huge quantities of data, and the data could be in any format, Excel, CSV, text, or it could be a direct connection to a database like SQL, MySQL, Azure, Oracle, anyone, IBM DB2. So it supports n number of data types or data sets, and it's very powerful in terms of data connectivity. So it uses powerful compression algorithms to import and cache the data within the .pbix file. So it's as convenient as a simple software. If suppose you import a data and then you prepare a report, and then you can easily share the reports with your peers or someone who's co-developing with you, either through Power BI cloud services, or even you can share the PBIX file in an email or through any other means, and you can share the data set with the concerned, and they can then work on the report independently. So there are different ways. There is no kind of a limitation for working on Power BI. There are multiple ways, and it is very fast. It is the most fast tool to work with Excel, because definitely Excel is also a Microsoft technology, so it works very fast on Excel based data. and gives you numbers and reporting at a very high speed. So now once you have imported the data, Power BI allows you to model the data, allows you to work intelligently on the data. It allows you to model the data in a way that if you are importing data from multiple Excel sheets, importing data from multiple tables, you can easily create a relationship between those tables or data sets in Power BI and then create visually appealing reports, meaningful reports, as I've been emphasizing, and make sense out of that data. No data in silos is of any use. Data in silo means a single worksheet or a single data set will not churn out any meaningful information until and unless you basically join it, club it, merge it, union it, append it with some other data sets, because a single data set will never be able to hold that much amount of information which is generally required for a important report. So it has easy drag and drop functionality with features that allow you to copy all formatting across similar visualizations. So just like in Microsoft Excel we use Format Painter to copy the format of one cell to another, similar features, very similar to Excel products or Microsoft products, they have provided that if you have applied a particular theme on a report, you can easily replicate that on any other report. The font, the header size, the background color, you don't need to do it again and again. So there's a lot of reusable features which are also available. Okay, now as I said, Excel is a Microsoft product, Power BI is a Microsoft product, so they have intercompatibility. You can publish data from Excel to Power BI. Now, with the latest developments and enhancements, as of today, Excel has also plugged in a new feature called Power Pivot, which I'll show you later down the line. But that also allows you to do a quick analysis. You can't create, of course, complex reports or fancy reports like Power BI, but Power Pivot allows you to create, quick measures, quick functions, quick calculations on your data quickly only in Excel. So it's an Excel plugin. But whereas, Power BI is also compatible with Excel. So when you create a report in Power BI, it gives you inbuilt feature to export your Power BI report into Excel format directly. You don't need to do any programming for it. Also, you can easily publish, when you publish your Power BI reports, it allows you to give some inbuilt intelligence of analyzing your reports in Excel, and it gives you all those features of exporting your Power BI reports into Excel, which is not available in any other tool, or otherwise those tools have to create plugins, create add-ins, and probably they might charge for it. But Power BI comes with a lot of out-of-the-box features which are very, very helpful for analyzing data in Excel and vice versa. Azure Cloud. Now Azure itself again is a Microsoft Cloud tech stack. So using Power BI with Azure allows you to analyze and share large volumes of data. So Azure, basically Azure database or Azure cloud servers are meant to hold huge amount of data, and Power BI allows you to have seamless connection. You can easily connect to Azure Data Lake. You can reduce the time it takes to get insights and increase collaboration between business analysts, data engineers, and data scientists. So Azure Data Lake becomes the central focal point where all your analysts, engineers can keep working on the centralized piece of data and churn out their reports. Data scientists' primarily job is to keep the data in a structured way, optimized way, optimize the input-output operations, disk operations, and memory utilization so that the reports also get churned out in a faster manner. So every person has their own role in order to give a quick refreshable report, a quick rendered report. Any report which is taking huge amount of time to get rendered will not eventually be used by the business users, because then it does not solve the purpose. The report should be fast. Report should have appropriate filters, slices and dices, you should be able to create the reports or dynamically, or you should be able to visualize the data dynamically. So all those visualization features are available in Power BI, and it works seamlessly, either it is small data or huge data. It allows that you to work on those kind of data in a seamless fashion. Right, so this is just a very quick example of how a typical dashboard looks like. Dashboard is nothing but, you have clubbed a couple of multiple reports on a single page, and if you change a filter, a single filter on the page, all the reports will honor that filter and the numbers will change accordingly. So if you see in this example, there is a filter or a drop down of product ID, product name, employee name, or supervisor, or a date range. So whatever date range or filter you will apply, all the reports on this dashboard will get changed based on the filter you have selected. So Power BI allows you to get insights from data and turn insights into action to take data-driven business decision. And that is the ultimate goal of any visualization tool. That is the purpose for which visualization tools are bought and purchased by the organizations, and data is fed into them. Now, Power BI fetches data from factory sensors, social media sources to get access to real-time analytics, so that you are always ready to make timely business decisions. So basically, there is a feature of live connection or cutoff data connection. So either you can work on data which is residing on a machine and you can just work on the cutoff data. Like for example, there's a data which is available for sales 2017, 2018, and you're just working on a historical data. It's a cutoff data. Or it could be possible that you want to be connected live to a real-time IoT based, sensor based data, or social media data like Twitter, Facebook feeds, or you're connected to live Google worksheets. That is also possible. You just need to publish your Google sheet for a public domain, embed the URL into Power BI, and then whoever updates that Google sheet, automatically the Power BI report will also start honoring and consuming the new data which is added in the Google Sheet. So all those kind of real-time streaming analytics is also possible, and that is one big feature and very important feature of Power BI, which is widely used and has a very huge market acceptance and market utilization. Now, what is Power BI? Power BI is a business analytics service provided by Microsoft that lets you visualize your data and share insights, right? So earlier, Microsoft used to have a technology called SSAS. Now they have replaced actually SSAS and SSRS with Power BI. So basically you can use Power BI on the data which is there in your Excel or any other data source, and the Power BI service or Power BI desktop basically creates a connection to those data sets and import it, cache it, and give you a handle to it in order to work with it. So you can create these fancy, meaningful visualizations. Like for example, there is a geographical map. If you are importing data for a country or a continent or a region, Power BI will automatically detect that it's a geographical information and give you a map with latitude, longitude information, and you just need to plot your numbers on the map. Either you can use bubbles or either you can use triangles or whatever data structure you want to use, but all the mapping will be available geographically. Then you can create pie charts, which is shown in this visualization. You can create tree maps. You can create cards where you can highlight the most important numbers like sales, total sales of your company across all the regions, or the growth chart, or the month on month sales of your organization, or total number of products or units sold. So whatever is important and to be highlighted for the management to take any meaningful decision or any insights you want to share, Power BI visualization tool, the Power BI visualization chart allows you to drag and drop and create wonderful reports. Okay. So what are the features of Power BI? So Power BI Desktop is something, a standalone tool which you need to install on your machine. It allows you to build reports by accessing data easily. You do not need advanced report designing or query skills to build a report. Though yes, it is beneficial that if you know some SQL programming, analytical programming, or you are aware of advanced features of any analytical tool, that might help you, but that's not a showstopper. You can easily build reports in quick turnaround time without needing any technical background. You just need to have some analytical mindset, and you can create savvy visualization and analytical reports. Stream analytics, as I mentioned, you can create a live connection with any kind of data. It could be IoT, it could be media, social media, it could be Google Docs, it could be any other kind of live connection. It could be a live database connection itself. So any insertions or updations or deletions happening will automatically reflect in your report. Yes, multiple data sources, and that has to be the primary criteria for any tool to be popular. If any visualization tool is limited to certain data sets, then it will not be highly acceptable in the market. And custom visualizations, right? So as I showed you certain examples in the past, in the previous presentation, that feature is very important because someone might want to look at the KPIs from a different perspective. Some management might want to look at the KPIs from a different perspective. So you need to have that capability to create different visualization from the same data set. Now let's take a look at how to install Power BI Desktop on your machine. So basically what you need to do is you need to go to this URL, powerbi.microsoft.com enus desktop. Okay, and you need to just enter this. Now you can download it for free. So just click over here and it will open Microsoft Store. So basically now what Microsoft have done in the latest operating systems is that when you are trying to download, you can actually directly go to the Microsoft Store and search for Power BI. So let's wait for a couple of seconds. Right here. So Power BI Desktop in Microsoft Store. For me, it's already installed, so it's asking me to open it. I'll open it in a while, but for anyone who is not installed, he will see the button of install over here, and it will automatically install in your machine, and then you can easily go and open Power BI Desktop. Now if I click open over here, now this is the UI of the Power BI Desktop. I'm not going to go right now in creating reports right away. We will talk about that in a subsequent session with sample data sets, and we will cover the features of Power BI Desktop one by one. But this is what it is. This is the whole tool of Power BI, which is having the visualization pane. All the different visualizations are can be created from this pane. Then this is the pane which allows you to select the data fields. Then there is a report view, data view, and relationship view, the data model view, where multiple relationships you can create. You can view the data in the grid of the tables which you will create, and the reports. So you can create multiple reports on multiple pages. You can keep adding pages. Either you can create multiple reports on a single page and it will become a dashboard, or you can create separate independent reports on the single page. And these are the menu options which we will talk about. How you can change color scheming, you can do data modeling, you can create new reports, and you can also transform data, which is the biggest feature. Extract, transform, and load the data, apply different logic, changing data types, massaging the information, creating new joins, appending the data, adding new columns, etc., etc. That is what you can do in transform data. So this itself is a whole different world. It's a dedicated topic. So we will talk about that in our subsequent sessions. So what's in it for us today? We will be learning how to connect to data, different data types, data files like Excel, PDF, then what are the different data importing modes, and then I will also show you practically different sets, how to import them in Power BI and use it for your visualization purpose. Now, what are the steps to connect to data? So now we will go directly into Power BI and try to import one by one few most commonly and popularly used data sets which are most commonly used in a day-to-day activity. Rest, of course, there are Power BI supports n number of data sources, but we will do something practical on the most popular ones. So let's open our Power BI. Now this is my Power BI, and first I want to show you that how can I import data directly from a web page and import the data. Now it is asking for a URL in order to import data. So what I have done is I have created a Google Excel sheet with simple data with rows and columns, and what I have done is I have shared this sheet as publish to web. Okay, so you just need to say publish to the web, the link as web page, and say done. It's automatically published, and say link. So copy the link which you have published on the web, copy this link, and then go back to your Tableau, paste that link over here and click OK. Now Power BI will try to establish a connection with this Google Doc sheet because it's published on the web. You need to wait for a while it is reading. Okay, now it has read one of the HTML tables, so I'll select this one. Now you can see it is showing me a preview of the table which is there on my Google sheet, right? It has 11 rows, so it has all showed all the 11 rows. So now I can go and transform this data because I can see my headers are there starting from the second row. So there's an opportunity for me to transform the data. So I'll go and transform it so that it looks clean. Okay, so first is I need to remove the first row, which is the null row. Remove the top rows. Okay, and then I need to use the first row now as a header. So you just click this option, use first row as headers. That's it. So now if you see my row ID, order date, ship date, all my data is now ready. So I can say close and apply. Click apply changes. Now this is an example of web data import. You can go and preview your data. Right? Now the biggest advantage of this data connection is that it's a live data. So for example, I insert another row. Let me change the order ID. I've changed some basic stuff, and it's auto saved. Control S. Now I'll go to my Tableau and I'll refresh. Now you can see as I refreshed my Power Query Editor, I clicked refresh all and I got my new row which is there in the live data. I got that fetched from my, okay, I got that row, the row ID number 12. So I have to say close and apply. Now you can see the new row, the row number 12 is now available in my new data set, in the data set, because it's a live connection. It's a live connection with the web-based Google Sheet. Okay, so this is one important way in which you can import data. Now let's try to import data from a text file. Now I have already prepared a text file called subcategories.txt. Now let me just open it in a notepad. Now it's a very plain simple file, tab separated file in which you have product subcategory ID, subcategory name and product category key. So basically to which product category this particular subproduct belongs to, right? So what I'm going to do is I'm going to go back to my get data option and I'm going to select text/CSV option and I'm going to select option mod product subcategories.txt. Okay, so now Power BI has identified that it's a tab delimited file, it has recognized the headers, etc. right, and I can now directly load this file. Okay, so now once the data is imported in Power BI, it is like irrelevant to me. It's a composite data import I am doing, right? So in my presentation, when I am talking about importing data, there are different importing modes, right? Data import can happen through different ways. Okay, one is direct query mode, in which I create a live connection to the database, which I'll also show you using MySQL and MS SQL Server. And also you can do a composite mode in which you can have data imported from Excel, plus you can have direct query modes. So you can have multiple modes to connect and create a composite data model, and that's what we are doing right now in our practical. So what we are doing over here is, one, we have imported data from the web. Second, we have imported data from a text table. Now, after doing text, now our next task is to import from CSV. Let's try another one. So now I have imported product subcategory. Now I'll import a CSV file. So again, I'll choose the option text/CSV. And now in this CSV file, let me open this CSV file and show you what is it. So this is a list of all my products, product key, product subcategory key, products, stock keeping unit, etc. A simple CSV file, and I'm going to import that. Okay, so now it is identified the delimiter is comma rather than a tab, and it has already recognized the headers correctly, so I'll load it. Okay, so now my products are there, product subcategories are there. For product categories, now what I have done is I have created a Excel mode now. So now Excel I am using to import my product category. So now I have to click on the option of import data from Excel, and I'll say product categories. Select the sheet, load, and now so my products, product categories, product subcategories, though with different data storage types, but still now the data is imported into Power BI. It is a composite data model. Now another very important data type which you can import is the PDF also, right? So what I have done is I have created a PDF called customers. My customers data is lying in a PDF. So what I have done is I have created a PDF which has data for some columns are there, like, you know, customer key, prefix, first name, last name, birth date, marital status, gender, email address, annual income, total children, etc., etc. So this is the data set which I have created in PDF. So what I'm going to do is I'm going to select PDF now and import customers.pdf, and see, it has recognized my table on page 1 which I'm going to load. Okay, you can rename this as PDF table. So this basically, these are the different type of data types we have imported: PDF, Excel, text, CSV, and web page. Now let's take a look at another interesting data set which we want to import, is the MySQL Server data set. So what I have done is I've already installed MySQL Server on my local instance, and there's already a schema of SQLite tutorial over there, and I have certain tables already prepared over there like department, employee, etc. So my goal is now to import this data or create a live connection with this data set. Now in order to import my SQL database connection in Power BI, you need to first download a connector, MySQL Power BI connector. So you need to go to this link and then click on download and install the MySQL connector. Based on the operating system you have, you click on download and install it. After you have done this, go back to Power BI and then give the IP address of the database. In my case, it's there in this local machine, and the schema which I want to import is SQLite tutorial. So I'll give the name, click connect. Okay, now it's connected. So now it is asking me which particular tables you want to create a connection with. I'm choosing department and employee, and I'm just loading them. Okay, so now this is the exact data which is there in the employee and department in MySQL. Okay, so this is one example of how to create connectivity between Power BI and MySQL. Now I want to do the same thing using SQL Server, Microsoft SQL Server. So I have also installed Microsoft SQL Server on my machine, and I have used the SQL Express. So this is the name of my server, so which I'll copy the server name and go to get data, select SQL Server, and for now database is optional. I can say direct query, click OK. Okay, now it is showing me what all tables I can import. So in my SQL Server tutorial, in my SQL Server, I have these three tables: customers, employee attrition, Olympic events. So I can use probably the customers one, which is now you can see this is the data, the customers data, which is lying in my SQL Server. Okay, so I can preview it and load it. So now you can preview the data in Power BI. That this is the data.
So I can rename as customers from MS SQL, and this is from MySQL, and okay. So now this is not the only data sets you can import. Now if you take a look at the options which Power BI gave, of what different type and variations of data it can it has compatibility to import from. Okay, so we can just take a look at the categorization on the left hand side first. There are file based like Excel, text, XML, JSON is also possible. You can evenly directly import an entire folder, and within the folder whatever data types of files are there, it will detect it. PDF, Parquet, or even SharePoint folder, which is itself a Microsoft technology. Then different kind of databases, SQL Server and MySQL we just saw, but it's not only limited to this. You can connect to Microsoft Access, SSAS, Oracle database, IBM DB2, Postgres, Sybase, Teradata, and then SAP databases, Amazon, Redshift, Impala, Vertica, Snowflake, and n number of databases which are there in the market today, Amazon, etc. Then it also allows you to connect with its own Power platforms, Power BI platforms, data marts, Power BI data flows, Dataverse, etc. Azure, there are different kind of storage mechanisms in Azure, and Azure itself is a Microsoft technology, so it has a compatibility with a lot of Azure based data storages like Azure SQL database, blob storage, Azure Databricks, right, Azure HD Insight Spark. So if you have those kind of services running on your Azure cloud services, you can even import them over here. Now online services, like you have ERPs running, or some data which is shared on the internet. If you want to import it, that is also possible through certain products. Dynamics 365, Microsoft Exchange Online, Salesforce, Google Analytics, Adobe Analytics, GitHub, LinkedIn Sales. If you want to do some analysis of some social networking, feeds, that also you can import. Then other miscellaneous are also there, web-based, Hive, R script, Python script, if there's something to import, get data from. Google Sheets, like we saw one example in our video right now. So there are multiple options available. Now, once you have imported the data which is relevant to you, in our subsequent sessions, we will see how to create relationships, but just giving you a glimpse that whatever data you are importing, Power BI auto detects certain relationships and it will create for you, but then you can go and manually also change. So this is the composite data model which is getting created in the backend while you are importing the data. You can easily go and manage these relationships, either keep them as is, you can delete and create new ones manually. So there is no limitation in that. So this is what we have witnessed. We have imported data from different files types, data types, and then we have tried to, once it is imported into Power BI, then there is no limitation of how you use it. You can create visualizations across different data sets and then create your standard reports. So this is the example of importing data from web, importing data from a database, from a PDF, and then once you have data, you can shape and combine data. You can basically do whatever transformation you want to do. You want to make joins, merge the data. So for example, if we go back to our Power BI, And if I go back to my transform data section, now as I have now different data sets available with me, I can do any kind of operation transformation on the data, right? So like I showed you, I upgraded the header row because one of the imported data was not showing the header correctly, or this column, like this exact one column is extra, I can remove the column, right? All those transformations, whatever I do in the backend gets captured in the applied steps section, right? This is the customer data. You can create, you can merge it, you can append it, with other data sets, right? Let's, for example, I want to create a merge data set of my categories and subcategories. So I can say merge, select these two data sets and say merge queries as new, and I can select product categories and product subcategories, select product category key on both the sides, and then they do a left auto join. So whatever product categories are there, I'll get the subcategories associated with it, and I'll create a new table which will have, now I have the table which has the category and the subcategory in one table itself. So I can rename it now to as category subcategory table. It's a merge. Basically, it's a join between category and subcategory, and now I have a common table, right? And I can close and apply. So imagine I have created a new table which is created from one data set which is Excel based, and another data set which is text based. See this category subcategory table. So now I can use it the way I want in my visualization reports. So that's what the presentation says, right? That once you have the imported data, you can shape, you can combine, you can adjust, you can do whatever transformation you want to do and create your visualization.
Okay, so what topics we are going to cover today? We are going to talk about different types of data modeling, and the most important part and aspect of data modeling is the cardinality. The cardinality which you basically decide after reviewing the nature of data, and after you've imported it, what kind of cardinality you have to basically highlight, right? And there are different type of cardinalities which you might have heard earlier also if you're from PL SQL background, like 1:1, 1:many, etc. We will talk about that. Now, what are the different types of data modeling? Now, dimensional data modeling is one of the most popular and most widely used modeling. In dimensional data modeling, you have master data, like for example customer data, date, store data, product data. So these are like less frequently changing data sets. So there is an organization, right, and you have set of customers, their email ID, phone numbers, etc. that will change less frequently as compared to the sales transactions, because transactions are happening every day, every minute. So sales is a more fast changing data set in dimensional modeling, which is in the terminology of data is also called as a fact, and customer, store, product, which are like more of static data and less changeable data, is sometimes called a dimension. So this is a typical dimensional data model which is typically used sometimes, right? And then there is another model which is relational model. This is a typical model which we have been using in database design, like primary key, foreign key relationships. So for example, you have a customer who has purchased a product. So probably the customer might have the details of the product which he has purchased, and you will make a join between customer and product table, and even you can make a join between product or product type or customer or product type. So customer table will also have a key to the product type. So this is less conducive for reporting, but it is more of a transactional relational model. But
Of course, this is also feasible. But from the Power BI perspective, when we talk about reporting and visualization, this is the most extensively used dimensional data model. And this is what we are going to see in our example now. So what I'm going to do is I'm going to show you certain data sets. First, we will prepare and create certain of our data sets, and then we will import in our sample Power BI file, and then slowly we will create the relationships. Now, one important thing which you need to understand, that in Power BI, if you go to Power BI, there is an option that Power BI auto detect new relationships after data is loaded and import relations from the data source on first load. So for example, if you are importing the data from a database where you have already defined the primary keys and the foreign key relationships, so that is the first option which Power BI will auto detect. And secondly, if suppose you are importing two different kind of data sets, one is Excel, one is CSV, and if Power BI detects a common column, key columns, it will auto detect a relationship which you can go and later change, modify, manage in your relationship menu, manage relationship menu in Power BI, which I'm going to show you. Okay, so if I open a Power BI, and this is where the option lies, go to File, go to Options and Setting, Options, Data Load, and these are the two options which are by default checked. You can uncheck it and manually prepare relationships. There's no limitation to that, but if you keep it checked, then Power BI will do its job to detect the relationships. Okay. Now coming to the next important factor, cardinality. Now before I start playing around with my data and start showing you certain relationships, it's very important to understand these four types of cardinalities. One is many to one, right? So basically, many to one means that many orders contain data of one customer. So per order, one customer is there. So from customer to order or product or delivery address, it's a one-to-many relationship. And from the other side, from order to customer perspective, it's a many-to-one relationship. Okay. Second, other cardinality is 1:1. 1:1 relationship is only applicable when you are saying it's an extension of the current table. So for example, in one table you have employee details and you are extending the details of the employee in another table like employee address, employee ID. So that is like 1:1. There is no multiple records of a single employee. In the address table, only one employee ID exists, right? Now 1:many, as I said, is the reverse side of many:1. So in customer table, only one customer record exists per customer, and one customer can place many orders for multiple products and can also have multiple delivery addresses. So that way, this is a typical 1:many relationship. We will be seeing this example also in our sample data set. And last is the many-to-many relationship. Now, many-to-many is a very typical example, so which I'm going to show you practically. And in our case, we will see that, like for example, you have placed an order for a particular product, but there are multiple fulfillments which has happened. So suppose you made order for 10 products, but at the back end, when the company is fulfilling, it is first fulfilling the first 2 products, then the rest 3. So basically the fulfillment is happening in batches. So one order ID might have multiple fulfillments for the same order ID. So there will be a many-to-many relationship, which I'll show you practically. So now with this background, let's start importing our data. Now the first important thing which we need to import is the master data. So first I'll import all my master dimensions which I'm going to use in my example. So first is the customers table, customers data. So this is the customer details, like customer key, prefix, first name, last name, birth date, marital status, and gender. Some redundant columns are also present, but we'll remove it. Now my customer data is loaded. Now today's session is all about this section of modeling. So we will keep our focus over here. Okay. Now some columns, probably some blank columns are there. I can select them and say delete from model. Yes. Okay. So now this is my customer's data with the relevant columns and the key per customer, customer key. Now there's no relationship in this model right now, right? Because only single table is there and the associate data is only imported. Now let me also import my another important master table is the products. Select the product data, product key, product subcategory, product SKU, product name, model name, product description, color, size. So just see all the relevant information only specific to the product is available. So I'll import it. Okay. Now see, there's no relationship between product and customers directly, because unless a customer makes an order, places an order for a particular product, there is no join, right? So now between these two tables, the most important, now another table which will now make sense is the sales order table, sales table. Now I am assuming that Power BI have auto detected the relationship. Now you can see that because I've already ticked that checkbox. Now let's see what relations Power BI has auto detected. Let's first check the relation between customer and sales. I'll double click this join. Now what it has done is it has created a join of many to one between sales and customer. So what does that mean is that one customer can place many orders, right? And that it has detected by the quality of the data and the data sampling which Power BI has done. You can also reverse this relationship. Here I can select customers and I can select sales. Now it has become one to many. So that you can also do manually. So that is what I said. Whatever Power BI is detected, it is up to the discretion of Power BI internal configuration and algorithm, but you can go and change it. So this is now you can make this is by default active. So we want to keep it active. One customer, many sales orders. Cross filter direction means that only from customers to sales is the filter applicable, not reverse. I'll come to this with my another example, but first let's change the relationship. So 1:many means from one customer and many sales orders. Similarly, let's see what has happened at the product side of the relationship. Similarly, Power BI, many sales orders for one product. You can, for simplicity's sake, you can say products, sales, product key is the join. Now just focus one more thing. Please also see the column on which the join is the grade column, grayed out column. Product key is also here and product key is also there, and it is what we wanted. So 1:many relationship from product to sales table and active. Now looks fine. This is something which is looking logical, and probably now we can proceed further to create a report. Now let me explain the cross filtering with an example. Now, for example, I want to check in a report that what is the count of products which a particular customer has ordered. Okay, so what I'll do is I'll select the product count of product name. Now if you see, and for each customer, in front of each customer name, the count is coming as 293, 293. It is getting repetitive because there is a one-way filter direction filter between customers and sales and products, right? So this join is single-sided. It means that from customer to product you can't find a relationship because it's a single side cross filter, right? What does this, if I change it to both, it means that it is equal to a join between product and sales, and every product detail now is appended to the sales table. So if I want to make you visualize this, you need to go here. I'll first open my sales table. We can also open it here. Let's make click this OK. Now if I click OK, you can see the single arrow is changed to double arrow. It means it's a both side filter. So when you say a both side filter, it means that implicitly within Power BI you can imagine that all the product columns now will get appended because of both ways filter you have applied. And if you go to your report now, see the change of the numbers now, 40, 20. So the total count of products across all my customers come out to be 293. Now the report looks correct. If I change the relationship from back to single between product and sales, then you can't make a join between customers and product. Basically, you can't derive the product count from the product table. See this. If you have to live with it, then you would have to go to the sales table, get the product key and get the value of count of product key, but that is not correct. Okay. So if you want a report in which you want the count of product name, and even if you want a count of distinct product name, so this will not come correctly. You would have to go and change the direction of the filter, which is from single to both. So this is a typical example there where you want to use a two-directional filter. Now let's proceed further and import other data set in order to show you another example. Now I want to show you an example of 1:1. So I have another table which is called customer details. So the key in this table is again customer key, but only email address, annual income, total children, education level, etc. Other details of the customer is there. So I'm loading the customer details. Now you see it has auto detected a 1:1 relationship. Wow, what is the meaning of 1:1? Means one customer key only has one entry in customer details. There is no multiple entry. So if you click this button, it's a 1:1 and the cross filter can be both or single, doesn't matter, because one customer will have only one value. You can make this as active. Okay. And if you go to the customer report table, you can now easily associate a email address with the first name. You will get 1:1 record. So now you can see that with 1:1 relationship, with the first name, I have associated the email ID, and for each email ID, there is a associated first name with that. So this is an example of 1:1 relationship. So in this example, what we have explained is that for each customer, there is an associated customer detail, right? So you have the first name, email address, education level, homeowner, occupation, and total children count. So in this report, what we have done is, if you click over here, so the first name and the email address. Okay. So there is a 1:1 relationship, and if you drag the customer key report takes time to render, and even if you can, so this is the reporting output. You have the customer key, first name, associated email address, and the count of product names which the customer has ordered. Now this is an example of 1:1. Now I want to show you an example of many to many. Now for that I'll import my fulfillment dataset. Okay, now in my fulfillment dataset, there is a column for order number. So basically what I'll do is I'll drag order number from here to here. Okay, so now what has Power BI detected? I'll do one thing. I'll select sales over here, fulfillment over here, and order number to order number. Okay, so it's a many to many relationship. So it means that per order I have created multiple batches to fulfill that particular order. Now many to many relationship is definitely a candidate for both ways cross filter detection direction, but you can check that. But definitely Power BI shows a warning that this relationship has cardinality to many, and this should only be used if it is expected that neither column contains unique values. Okay, so we know that fact. That's why we are accepting this relationship as many to many, because we know there are multiple order numbers over here in the sales table which are mapped to the multiple order numbers in the fulfillment table. We'll click OK. Now you want to keep the direction as both ways or one direction. That is up to you, the way you want to map the report. So I can double click over here, and you can even click. So now you can select from which way single filter you want, from fulfillment to sales or sales to fulfillment. I'll prefer sales to fulfillment and click OK. Okay, now we have all our different kind of relationships over here, which we have tried to shortlist: one to many, many to one, one to one, which is this example, and many to many. Now if I show you further relationships which you can keep on adding, like for example I have the example of territories. Now in which particular territory the sales was done, so I can map it over here. Okay, so now it's a typical 1:many relationship, because territory is my master table where I have a static list of continent, country, region, and it is mapped to the territories which are in which my orders have been placed. So it's a typical 1:many. So that way, you can keep on adding data. Then you have details of returns. Now this is another transactional table which is about the orders which have been returned rather than being returned by the customers. So you have a product key, so automatically Power BI has detected a relationship between the product key and the product table, right? And even if you can join the territory key, in which territory the return has happened, right? So mostly the most common relationship which you will observe is the 1:many, because as I told earlier, the most common relational model is the dimensional model. The static data, the slow changing dimensions, the SCDs, are the master tables, and the most frequent changing are the fact tables. So if I talk about a typical dimensional model, the fulfillment table, sales table, and the territories table, the fulfillment table, sales table, and my returns table are the fact tables of my data model. Now, so far, what we have done as per our last session is that we did data modeling on the different data sets which we had imported in Power BI, like products, sales data, returns, fulfillment, customer details, and customer master data, calendar details, etc. So in the last session, we prepared a data model and established the relationships between these different data sets, like 1:1, 1:many, many to 1, 1:1, etc. And we saw the examples. Now, once our relational model is prepared, our data model is prepared, now our next activity is to create certain additional columns which we want to derive basis the data which we have imported. So for example, I'll start with my product data set. Now in my product data set, I want to introduce a column which basically categorizes that if any product which has a color red, black or gray, I am going to tag it as a colored product. Rest I'm going to say not a colored product, right? So all these are like example of byte type product SKUs. So for that, now in order to introduce a new column, you just need to do what? You need to select the table in the data grid, go to the table tools and say new column. Okay, so column will get appended to the rightmost part and you will start seeing a formula section typical to like you get in your Excel. Now I'm going to say that the name of my column is going to be byte type color. Okay, and I'm just creating a if condition. If product color is equal to black, okay, or if it is equal to red, or if it is equal to gray, then say yes, it's a colored product, else say no. Okay, so now you can see basis the product color red and black, they are saying byte type color yes, blue is no, multi is no, etc, etc. So this is a classic example of an if and else condition based conditional column. Okay, so you can create such columns. Now second column, custom column, which I want to create is I'm going to call as discount. Now basis the pricing of my products, I want to associate certain discounts which I am ready to give to my customers basis the product category, like what is the pricing of the category. Again I'm going to make use of if else, but in a nested way. So if I am saying if my product price is less than 100, then I will give 0% of 0% of discount. So 0 into product price, just to keep it consistent. Now I'm saying else, if less than 100 then 0, else I'll check again that if the price is less than 500, then I'm ready to give 1% discount on the product price, else I'll move further. So like this, I have created a formula. So what I'm saying is, if product price is less than 100, give 0%. If it is less than 500, then give 1%. Less than 2000, then 1.5%. Less than 3000, then 2%. And otherwise, else less than 3000, if it 2%, else 3%, right? Now, after this column is created, now you can check, right? So this, see, the product price for this particular product, it is less than 100, so that's why there is no discount. It is between 100 to 200, then this has been given a 1% discount. So like this, all the discount column is now calculated. Now this column is available just like a regular column in my product table. Now after this, I'll go to my sales table. Now in sales table, I want to identify, create a column called as cost. There is no product cost column over here, so that will be derived. So let's create a column called as cost, and it is derived by order quantity into, now the cost of the product is in the product table, and I know I've already created a relationship between product and sales table. So I just need to select the product cost column. Now only keyword which I have to use in Power BI is the related keyword. So this will pick up the relation, and now for this particular sale order, the cost has already been derived. So this order number, this is the cost for which the product is the costing of the product for this particular order. Okay. Now I'm going to create another conditional column over here called as order status. I'm saying if any order whose order quantity is greater than 2, then for my organization it's an urgent order, else it is a normal order. Oh, sorry, I lost it. So this is my order status column, and I have my order quantity, urgent or normal. So any order which has order quantity 1 is normal. Any order which is having order quantity as greater than 2 is urgent. You can see this. So there's this whole Power BI tabs and sheets allow you to also review the data, what you're doing. So it's very convenient. Now I have my sales data. Now what I want to bring within the sales is my discount column. So here also I want to bring the discount which I have created. So I'll say discount. Discount will be order quantity into related product discount, right? So the discount calculated column which I had created under products, I'll bring over here. Now I am creating the order level discount. So if you see, for this particular order there's a 25 for 25 rupee discount at the cost is 100,000 rupees. Okay, and what is the order price now? So I have taken the order cost, the discount. Now I have to create a column called as price, order price. So that will be again order quantity into related price, which is per product price, enter. Okay, so now I have the cost, the discount and the price, right, available with me. Now I want to calculate the total revenue, total profit and loss, right? Per order, how much? So first I'll calculate per order how much revenue I am generating. So now I have to generate a column called as revenue. Revenue is price minus discount so 1700 minus 25, 1700 minus 25, 2071 minus 42. And if I want to calculate the profit per order, then it is revenue minus cost. Okay, so now you can see, typical custom columns, calculated columns which we have created are all playing around with the numeric values, numeric data primarily, and trying to give inferences into per order cost, discount, per order price, revenue and profit. So typical calculation columns which I have prepared in front of you. Now let's take a look at other different variations of custom columns. I'll create certain columns for text-based custom columns, calculated columns using text-based data. So I'm now moving towards my customer table, in which I have customer key, prefix, first name, last name, birth date, marital status and gender. Now I want to create a new column in which I want to derive the age of each customer as of today, right? So I'll use another function, a date function called as date diff. Now date diff, so I want the difference between the birth date of the customer and as of today in years. Okay, so this customer as of today is 68-year-old, one is 74, 68, 57, etc. So this is one derivation of a calculated column of age. Let's take another example. Now this is a text-based column where I want to derive the full name of the customer. Now here I'll say first lowercase. In lowercase I'll concatenate the prefix, then ampersand, space, ampersand, first name, ampersand, space, ampersand, last name, and closing brackets, etc. Full name. Okay, so this is an example of full name in lower cases. Now another calculated column, conditional column. At the customer level, I want to identify a flag which says who is my target customer basis the demographics shared over here. Target customer. So I'll say if the marital status is equal to M and total children, and total children annual income. So okay, so let me change the logic a bit. So marital status is M and age is less than 50. These customers are my target customers. Okay, so I would say yes, else no. See this. His marital status is married, Logan Diaz, and age is less than 50, else everyone. So if I try to filter, so these are my target customers. 69 out of 1178. So this is just a conditional column, but a logical condition, an example which I'm trying to highlight over here. Okay, now let's look at certain calendar date oriented columns, calculated columns. Very typical, like now I have a simple date column. Now I'll keep adding certain columns which which will help you understand how you can do some calculations on the dates. So like for example, I want a date which is 12 days after the current date, the date in the column. So just simple 12 days after, select the date and add 12. Now if you see the date format, you can go and change the format at the top, and if whatever you feel like this. Now see, 12 days after 1st Jan 2015 is 13 Jan 2005. You can go and change the format and other details. Let me also show you, if I go to my cost and other columns, I can go and change the format. This is like a currency, cost is currency. So I can go and change the currency type, and you can even show the dollar value or whatever currency type it is. So for numbers, you can do currency, or text or dates, you can select the format. So this is available at the column tools level. Now in customers, like we had our column of full name. So now what all things are available? Format as text, okay, data type text. So very minimal options are there. With date, you have options of the date format. Now next, I want a column which defines the expiry date. Okay, so 8 months prior to the expiry date which is coming up in 8 months. So I'll create a column called as 8 months expiry, and then there is a eDate function. I'll use that. I'll use my date in the data set, comma, I'll say 8. So now this date column will append 8 months to my actual date, and again I can go and change the format. Correct. Now another important column, like I want to know the date name. So I'll use a function called as format, and I'll select my calendar date column, and I'll say give me the DDDD format of it. So it will give me the day name, the day name of on that particular date. Next, years in between. So I want the years in between the today's date and the date of my calendar. So equal to date diff, the calendar date, comma today, comma year, end. 7 years, 2015 to 2022. Then last date of the month. So if I want what is the last date of this particular calendar month, I will use a function EO month, which is there available in the Power BI. So I'll say last date of the month equal to EO month. Then just select the calendar CSV date, comma 0 in months, and enter. Change the format. Then similarly, start of the month. So I'll use a function called start of month. So for all January dates, end of the month is 31st Jan and start of the month will remain 1st of Jan. Change the format. Next, I want to know what is the week number of that particular date. So now there is an inbuilt function called week number, week num, and just pass the date and you will get the week number. First week of the year, second week of the year, etc. Now another very good example is whether the week day is a weekday or a weekend, right? So what is it? It's a week type. Okay. So I'll put a if condition and there is a function called weekday and I'll pass the calendar If it is less than 6, it means it's a weekday, else it's a weekend. So all Saturday and Sunday day names will come as weekends, or else everything else will come as weekday. So these are very different variations of different column types, calculated columns, which is a very important utility, and any Power BI project you will definitely be ending up creating n number of calculated columns to derive your numbers, to prepare your reports. But it's important to understand what all things we can do. Yes, there are n number of functions available in Power BI. But what I have tried to showcase over here is some important functions. But basis your utility, basis your problem statement, you can look up for a relevant function in the Power BI dictionary. Now, with this introduction to calculated column, this is the base for us to now get into our next session, where we will be talking about creating DAX measures and DAX functions. We will be using Power BI DAX functions, which is much more powerful than simple calculated columns, where you can do more complex calculations. You can calculate totals and then use them in the reports. So for that, we will look up into our next session. So I hope you guys had a great learning session, and I'll meet you in my next session. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.